One of the most requested video topics of the last few weeks in the comments section here and at Event Horizon has been the BLC1 radio signal. This story suddenly went hot again after being cold for years, amid rumors that there was some discussion of it still within SETI circles as a candidate signal, originating from a YouTuber as a potential alien signal. This is very much not correct, and either stems from a very bad understanding of what happened with that signal, or something bordering on a hoax that certain unscrupulous media outlets have further latched onto, and otherwise has gotten out of hand. But let me be clear, BLC1 is no longer a candidate for an alien signal. It was overwhelmingly likely to have been Earth interference, and now sits in the history of SETI as an initially interesting candidate signal, though never really a strong one, that ended up with a much more mundane explanation. I'll repeat, this one was not aliens. There is a lot of very bad information about this signal floating around right now, so I thought it best to address it and set the record straight, and then tell the story of what really happened with that signal. BLC1 stands for Breakthrough Listen Candidate 1 and was the first major candidate signal found by the Breakthrough Listen project, a privately funded SETI experiment. The signal was detected and recorded in April and May of 2019 for a total of 30 hours, and then announced on December 18, 2020. There are many problems with the attention this signal is getting lately, and that's the first one. This is an old detection from several years ago. It is not new. The second problem is that it came from the direction of Proxima Centauri, the closest star to the solar system. This was bad news from the start because it really is unlikely that the first signal from an alien intelligence would come from quite literally the next star system over. The odds of that are terrible, that you would have two civilizations at roughly the same technological state appearing right next to each other, coexisting at the exact time both have radio. If that were the case, then it would mean that the galaxy is absolutely full of alien civilizations. We should see them everywhere we look, and we do not. Remember, it's not called the Great Silence for nothing. It's because of a profound silence that we see from aliens so far, if they are indeed out there. Of course, one way such a thing could happen is if you had a galaxy-spanning civilization, colonizing every usable star system. But if that were the case, we should see signals from multiple nearby stars, not just one. It should be most of them, and we do not see that. But that actually would be a spooky scenario if we did see all the stars around us colonized, but our system left alone for some reason, because that would strongly suggest that we live in a zoo. It's one of the ways of confirming the zoo hypothesis. While we don't see aliens everywhere, it may be the case that somewhere out there is a civilization stuck in that state of affairs, perhaps in a galaxy far, far away. It would mean that such a civilization is effectively locked in at the hands of a superior civilization. In that case, the galaxy is already spoken for, and they won't be able to colonize nearby stars because someone is already there that is presumably much more powerful, and that someone is deliberately forcing isolation on the losing civilization. Had BLC1 been a truly anomalous signal, we'd have had to start asking ourselves that question: are we being isolated? Of course, we still could be in that situation, by something actually even worse: silent aliens enforcing a zoo. But you'd have to wonder if anyone could ever tell if they lived in a zoo, since you can't see the zookeepers until it's presumably too late. BLC1 was initially detected at the frequency of 982.002 MHz, and this is yet another problem with the signal. When SETI looks at frequencies like the hydrogen line, the famous 1420 MHz where the WOW signal was, the area on the dial around that frequency is supposed to be silent. And for more reasons than just SETI. It's very useful in radio astronomy for studying the hydrogen clouds of the Milky Way, because neutral hydrogen emits radio in this range, and it was long ago set aside by international agreement for astronomy. No one broadcasts there, or at least they're not supposed to. 982 MHz, however, is a nightmare. This is UHF, folks. And that area of the spectrum is home to radar, television, mobile phones, Bluetooth, two-way radios, wireless networks, amateur radio, satellite downlinks and radio, emergency services bands, weather satellites, cordless phones, and many other things. And every single one of them is a source of interference. But it is also searched in radio astronomy using filtering to remove the interference. But that does not work all of the time. A big tick in the box against BLC1. The study was actually scanning about 800 million channels at once, ranging from 700 MHz to 4 GHz. Interestingly, this range is also home to the microwave ovens. Many will know the famous story of the Parkes Radio Observatory picking up their break room microwave oven in 1998. That story was somewhat misreported as well. The scientists did not think the weird signals they were getting were aliens. They knew they were very likely terrestrial in origin, though they did wonder if it was lightning. What it turned out to be was the microwave. Some employees would prematurely open the oven door before its magnetron completely shut down, and radio energy would very briefly escape, and look something like a fast radio burst does. They did experiments with the microwave, and sure enough, it was the culprit. BLC1, oddly enough, was detected by the Parkes telescope as well. But the telescope's beam actually was rather wide. It was pointed roughly at Proxima Centauri, but the signal could also have come from anywhere within about a 16 arc-minute circle in space. So there was always the possibility that it was a much more distant signal. The signal showed a very pronounced Doppler shift in its frequency profile. But it was the opposite of what you should see from the motion of the Earth. It actually increased in frequency rather than decreased. That's not what you would expect to see from a signal of alien origin in this case. It's also worth noting that other than the 30-hour window of observation in 2019, BLC1 has never been seen again. So even if it had remained unexplained, that would have put it in the same boat as the WOW signal, in that it did not repeat. Therefore, it could not be confirmed. You really need at least multiple observations. Better to have multiple telescopes doing the confirming, so that you can absolutely eliminate that it's not just noise in the telescope's receiver. BLC1 did not pass that test, which means it was never a great SETI candidate, just a spurious signal of interest. But in fact was actually less of a signal of interest than WOW was. But there is one standard procedure that SETI scientists do with a telescope when they get a signal. They wag the telescope by pointing it on target, then off, and seeing if the signal disappears when it's off target. That eliminates a lot of possibility for a glitch in the receiver and some types of interference. And Parkes is really isolated from radio interference, as best as can be done, but it still picks up tons of it. BLC1 did in fact pass this filter, which is why it was of interest. It would not have been if it hadn't. And that was another problem. Right at the same time BLC1 was first making the news in 2020, a few days before that there was an unrelated paper reporting a detection of a very bright, long-duration optical flare that coincided with radio bursts from Proxima Centauri, also based in completely separate observations done right at the same time as the BLC1 observation. If BLC1 had survived scrutiny, that occurrence would also have muddied the waters of the signal, because perhaps there was a way for the star to shoot out a narrowband signal in a way that we haven't thought of yet. But it's actually worse, because that flare very much stands against any of the planets around Proxima Centauri, including Proxima b, being able to possess atmospheres and support habitability. The flares would have blown all that away long ago. But we also don't know the direction in which Proxima Centauri flares. If it does it at its equator, that's it for the planets. But there have been other papers that suggest red dwarf flare stars actually erupt closer to their poles, meaning that the flares would miss the planets, opening red dwarfs back up for habitability. That's still up in the air, so there is still hope for red dwarf stars. And there are quiet ones, but Proxima Centauri is not. The end for BLC1 as an interesting signal was in late 2021, when two papers were published that called it very much into question. One was a new search of the dataset overall, observations taken at different times, and a bunch of other signals very similar to BLC1 were found. These did not pass the wagging filter, but they otherwise looked very much like BLC1 in profile. Taken with the other signals, Basically, the whole thing started looking like the signals were coming from oscillators in electronic devices. In other words, human interference. It just mimicked what might be loosely expected from a legitimate SETI candidate close enough to pass the computer filtering that kicks out most interference. It does have to be said that the specific source for BLC1 has never been identified, but that holds true for the vast majority of mistaken signals picked up by SETI. There are plenty of human radio sources, and some of them are secret spy satellites that no one knows what frequencies they transmit at. But the chances of BLC1 being an alien signal are minuscule at this point, and almost certainly it was just interference. And it wouldn't matter anyway, since any strong SETI candidate would have to be unambiguous, and BLC1 never was. But in this there is an interesting thought. We assume that alien radio signals would either be straightforward, such as someone's radar, or signals intended to be intercepted as contact signals, and thus would be as unambiguous as the aliens can make them. But there is another possibility, that of decoy signals and deception by an alien civilization. For example, if you want to hide your home world, be radio quiet, but knowing that there are other ways to detect technosignatures, it might pay to go to a nearby star system and set up a huge transmitter to look as though that is your native star system when it isn't. Far future humans might find themselves heading to the stars, following an enticing signal beckoning them to come, only to find out that it was a trap, and that something in that system was lurking there to take out any industrious civilization crossing space in order to keep the real homeworld concealed. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently eyeing the Halloween candy longingly. I almost entirely gave up sugar several years ago, so all I get is sugar-free candy, which isn't bad, but sorely lacks in variety, such as life. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.